everyone. So in today's lecture, we are going to solve some numerical based on Bessel function. So problems on Bessel function. Bessel function. All right. Problems on Bessel function. Good. So our first question is show that Bessel function, Bessel's function, which is denoted by Gnx, is an even function, when n is even and is odd function when n is odd. Good. So question says show that the Bessel function is an odd even function when n is even and it is odd when the n is odd. So if you remember, for even function function must be f dash of minus x will give me f of x, and for odd function f of minus dash of x will give me minus of f of x. Good. So this we had to remind. Now we know Bessel function over Jnx is it's simply summation r tends to 0 to infinity minus 1 to the power r upon factorial r factorial n plus r x upon 2 to the power n plus 2r. This we had already derived in our previous lectures. So question says this, show that the Bessel function Jnx is an even function when n is even, and odd function when n is odd. So we need to check this. All right. So just to fulfill this condition, replacing x by minus x. Fulfill this condition in equation 1. Say this is equation number 1. In equation 1, we get Jnx minus of Jn minus x will give me summation r tends to 0 to infinity minus 1 to the power r minus 1 to the power r upon factorial n plus r minus x upon 2 to the power n plus 2r. Alright. So our first case is, say this is equation 2. Our first case is case 1. If n is even, then we can say n plus 2r is also even. Why? 2r will always give me an even quantity. So even plus even will always be even function. So n plus 2r will be, so if n plus 2r is an even function, so I can write x upon 2 to the power n plus 2r will give me x upon 2 to the power n plus 2r. Alright, just replace this in equation 2. This will give me j minus nx, jn minus x will give me summation r tends to 0 to infinity minus 1 to the power r upon factorial r factorial n plus r x upon 2 to the power n plus r. Good. So this is nothing but jnx. So we can say jn minus x gives me jnx. So this is This satisfies our f dash minus x will give me fx. So this is nothing but an even function. So we can say, hence we can say g and x is an even function. Alright. Now just to justify the second case, just to our second case is case 2, case second. If n is odd, if n is odd, then n plus 2r is odd. Why? If n is even, say odd, and 2r is always even. So if you remember, odd plus even will give me odd. How? 5 is an odd number, 2 is an even number, so this will give me 7. 7 is odd. Alright, so n plus 2r is odd. So we can say minus x upon 2 to the power n plus 2r will give me minus of x upon 2 to the power n plus 2r. Alright, so from equation 2, jn minus x gives me summation negative of r tends to 0 to infinity minus 1 upon r 1 factorial r factorial n plus r x upon 2 to the power n plus 2r. This negative sign I put it here. So this is an gn minus x gives me minus of gn x, which shows that odd function, odd function, odd function. Just remember, minus of f of x will give me minus of f of x is an odd function. Alright, so hence we can say jnx is an odd function, is an odd function. Good. So on starting, so this is the numerical. If we take the second numerical says prove that j half of x is 2 upon pi of x into sine x. This is what we have to derive. So if I look closely on the right hand side, so this is a sine x and some constant. So I know left hand side is an Bessel function. So Jnx we know already. We know that Jnx is summation r tends to 0 to infinity minus 1 to the power r upon factorial n plus r x upon 2 to the power n plus 2r. So on left hand side we can see there is some series, and right hand side we can see there is sin x. So sin x can be expanded in its series form. So I know on the right hand side we need to maintain this series in terms of sin x. So if you remember, in our previous lectures we have already expanded this. So this is nothing but x to the power n, 2 to the power n, gamma function n plus 1. Why we are taking in gamma function? Just because we need to calculate 2 upon root 2 upon pi x. So pi is only available if there is a gamma function. So we had taken x upon n to the power n gamma function n plus 1 series from 1 minus x square upon 2 dot 2 n plus 1 plus of x to the power 4 2 4 2 to the power 2 n plus 1 n plus 2 minus and so on. This equation already we had derived in our previous lectures. Please do check also these videos. Alright, so just put n equals to half in this equation. So this is equation, uh, say this equation 1. Alright, put in equation 1. So this will give me half of j half of x to the power half upon 2 to the power half. This is half 1 plus 1 minus x square upon 2 dot 2, 1 upon 2 plus 1 plus x to the power 4, 2, 4, 2, 2. This is 1 upon 2 plus 1, 1 upon 2 plus 2, minus 1. Alright, just j half x will give me root of x. This is root of 2. This is gamma function 3 upon 2. 1 minus x square upon 2 dot 2. This will give me 3 upon 2 plus x to the power 4. 2 dot 2, 2 dot 4 dot 2 to the power 2. This will give me dot 3 upon 2 dot 5 upon 2. Alright, so I can see this is cancelled. This is cancelled. One power will cancel out here. So minus. So I can see root of x upon root of 2. I can write gamma function as 1 upon 2, 1 upon 2. Why? Because I know gamma function n is equals to n minus 1, gamma function n minus 1. Alright, here 1 minus x square, this is 1 dot 2 dot 3 left, plus x to the power 4, 1 dot 2 dot 3 dot 4 dot 5, minus 1. Here we cancel out only root 2 left, so root 2 root x can be written here, and this function can be written as gamma function is root pi. Alright, now we need to form this sequence as sin x, so I just multiply and divide by x here. So I just divide by 1x and multiply by, so this is x plus x cube, sorry, this is negative x cube upon 1 dot 2 dot 3 plus x to the power 5 upon 1 dot 2 dot 3 dot 4 dot 5 negative 1. Alright, just cancel this. Here root x left, so this is 2 upon root pi root x. I know this gamma function 1 upon 2 is root pi. Alright, so the left quantity x cube upon, we can write this is factorial 3 plus x to the power 5. This can be written as factorial 5 negative 1. Alright, so this can be written as 2 pi x root of, and this is nothing but sin x. Alright, so if we don't remember, sin x can be written as x minus x cube upon 3 factorial plus x5 upon 5 factorial minus 1. Alright, so this is j half x. So this is what we have to prove. So in this, you just need to remind this series form. Alright, so you can calculate easily. Thank you.